Welcome to 5.1 Trigonometric Identities, Example 4. Rewrite the expression in terms of sine theta and cosine theta. Then simplify the expression so that no quotient appears and functions are of theta only. One common strategy for simplifying or rewriting expressions is to put all trigonometric functions in terms of sine and cosine. We are also told that we do not want any quotients. So that means that we do not want our final answers to have any division or fractions. A, sine theta minus cosine theta times cosecant theta plus secant theta. We have two options here. We could either multiply this expression out first or write everything in terms of sine and cosine first. I will multiply them out first and then write everything in terms of sine and cosine. Sine theta will multiply by cosecant theta and secant theta. Negative cosine theta will multiply by cosecant theta and secant theta. Now we are ready to write cosecant theta as 1 over sine theta and secant theta as 1 over cosine theta. To simplify each term, we can write the function sine theta as sine theta over 1. Multiplying straight across, we get sine theta times 1 is sine theta. And on the bottom, 1 times sine theta also gives us sine theta. We can multiply the other three terms out similarly. For the first and last term, we have sine theta over sine theta and cosine theta over cosine theta. Anytime we divide an expression by itself, we get 1. We might also observe that sine theta over cosine theta is just tangent theta, and cosine theta divided by sine theta is cotangent theta. Now we have 1 plus tangent theta minus cotangent theta minus 1. 1 minus 1 cancels, so our final answer is tangent theta minus cotangent theta. 1 plus tangent squared theta divided by 1 minus secant squared theta. For this expression, we could try to use a Pythagorean identity immediately, or we could first write it in terms of sines and cosines and use a Pythagorean identity later. I will go ahead and write tangent squared theta and secant squared theta in terms of sine and cosine. Tangent squared theta can be written as sine squared theta over cosine squared theta, and secant squared theta can be written as 1 over cosine squared theta. Now we have a complex fraction. One strategy to handle complex fractions is to find the least common denominator of all of the interior fractions and multiply the numerator and the denominator by that least common denominator. Since cosine squared theta is in both of the inner denominators, our LCD is cosine squared theta. Now we can multiply the top and the bottom of this overall fraction by cosine squared theta. When we multiply the numerator and the denominator by cosine squared theta, it's important to remember to distribute the cosine squared to both terms. In the numerator, when we multiply this cosine squared theta by 1, the first term will be cosine squared theta. When we multiply cosine squared theta times sine squared theta divided by cosine squared theta, the cosine squareds cancel and we are left with sine squared theta. In the denominator, we also must distribute the cosine squared. When we multiply cosine squared theta times 1, we get cosine squared theta. But when we multiply 1 divided by cosine squared theta by cosine squared theta divided by 1, the cosine squareds cancel and we are left with 1. We might recognize a Pythagorean identity. We know that sine squared theta plus cosine squared theta equals 1. Since we have that in our numerator, we know our numerator will equal 1. Our denominator is cosine squared theta minus 1. Let's see if we can manipulate our original Pythagorean identity to get cosine squared theta minus 1. Let's try subtracting cosine squared theta from both sides. We will get sine squared theta equals 1 minus cosine squared theta. However, our denominator is cosine squared theta minus 1. Notice the cosine squared is positive and the 1 is negative. Let's try multiplying everything by a negative 1. Now we have negative sine squared theta equals negative 1 plus cosine squared theta. This could be written as cosine squared theta minus 1. Therefore, we get negative sine squared theta equals cosine squared theta minus 1. Since our denominator is cosine squared theta minus 1, we can now replace our denominator with negative sine squared theta. If we pull our negative out front and we square the quantity 1 over sine theta, we can see that we can now replace 1 over sine theta with cosecant theta. Thus, our final answer is negative cosecant squared theta. Example C. Tangent of negative theta divided by secant of theta. Recall that our negative angle identities tell us that the tangent of negative theta is simply negative tangent theta. Therefore, we can rewrite tangent of negative theta as negative tan theta. Now we are ready to write tangent theta as sine theta divided by cosine theta and secant theta as 1 over cosine theta. Because the fraction in the numerator and the fraction in the denominator have the same denominators, the cosine thetas will cancel. Therefore, we get negative sine theta over 1, or simply negative sine theta. I hope you enjoyed this video. See you next time.